Sorry about that. I guess we lost our connection.
No worries. We're still working out the bugs in the network.
Climate Bomb is working fantastic, Felicity. Bit of a change from the last time we talked. As I was saying, our mission right now is to keep the average temperature of the whole Earth from rising more than 1.5 degrees above what it was 100 years ago. Beyond that point, the impacts of climate change become very hard to handle.
So how high has it risen so far?
We've risen 1 degree, so we're 2/3 of the way there.
Okay, not the greatest news, but good to know. This would definitely motivate our agents.
And I see change agents waiting for you, Felicity. I'll leave you to it.
Excellent, you're here. Welcome everyone. Welcome to your training day. I hope you're ready to become change agents in the battle against climate change. We're almost ready to start.
I'm almost ready. My food is stuck again.
Lowest uncle in the world. While we're waiting, let's take a look at the trainee tablets in front of you. If you haven't done it already, unlock your tablet by placing your hand on the hand symbol in the middle of the screen. Your trainee tablet will assign you a secret agent ID. Remember, then choose your avatar. You know, a picture that represents the kind of change agent you want to be. So, introductions. I'm Felicity, one of your trainers for the day. Down in front is Bo, our artificial intelligence agent, who helps us run our global network of change agents. And, better late than never,
Agent Sheepy here. That's right. I'm a sheep. We're all sheep. But we're informed sheep. Informed and concerned about climate change. In fact, we've been so concerned about climate change that we've converted our cozy burn here into this high-tech, state-of-the-art training burn.
that's true, Bo. You created our agent network. And yes, we make the music too. This training barn is where we take ordinary human beings like you and turn them into change agents. People taking action against climate change.
Because we sheep have been observing you humans, and we've noticed that you already know quite a bit about climate change, but you seem to have more trouble acting on what you know. This is where your agent training comes in two very important ways. First, we're going to make sure that you have a basic understanding of the science of climate change, so you can speak to others with confidence and clarity. And second, we're going to help you take action. A good agent sees what needs to be done and then does those things.
Nicely said, Agent Sheepy. Shall we get started? I'll want someone tell you that during your training, we'll send you messages on the training tablet. So, keep an eye out for those. You can also use these buttons to collect things you want to learn more about, or things you want to get involved with. Good? Okay, let's get training. Bo, please initiate the first training module.
Never in the history of the universe, which is a very long time, have we had a better view of our planet Earth. Satellites give us so much information about our planet. Up-to-the-minute data on wind, rain, snow, the temperature. You know, the kind of stuff you see on the weather report. But here's the point, and I can't stress this enough. As a change agent, you must never confuse weather with climate. Yes, they are related, but they aren't the same thing. Weather is what's happening in the atmosphere right now. Oh, what a beautiful day. Let's go to the beach.
Oh no, it's raining outside. That's your umbrella.
Weather is what happens on any given day, but climate is the pattern in the
Windy.
weather over time. You know, the kinds of weather that different places on Earth come to expect during any given season. Seeing climate change means watching for change in those overall patterns.
The best way to see climate is with data. A change agent has to love climate data. Maybe not love one. I'll show you what I mean. Bo, please call up the global temperature data from the last 100 years. Perfect. The colors on the map represent temperature. Blue is cooler and red is warmer. You're looking at the global average temperature starting from about 100 years ago. As we play the data forward in time, you can see how more and more regions on the map become darker red. Like I said, red means warmer, so more red over time means a warming Earth. Bo, please play that again. This time a little faster so we can really see the change. Let's graph it too, so the trend is really obvious.
This warming trend is really important because the extra heat energy in our atmosphere is at the heart of climate change. This is the 1 degree rise in global temperatures over the last 100 years or so. And if, as change agents, we're going to keep the global temperature from rising even more, we need to address what's causing it. Bo, it's time for the infrared experiment. Bo? I think I broke Bo.
No, you didn't. She's just waiting for you to say please.
Sensitive AI. Bo, can you please load in the infrared experiment? Pretty please?
Everyone wait to the camera. You're being filmed by a thermal camera that's sensitive.
There, we can see that.
To this camera, warm things are red and cooler things are blue. Of course, we're all warm-blooded mammals here, so anywhere you have bare skin, like your hands and face, the camera sees as red. But anywhere you have clothes on or a fleece, your body heat stays trapped next to your skin, blocking most of that heat from reaching the thermal camera. The Earth's atmosphere behaves a lot like your clothes or our fleeces.
Exactly, Felicity. Well said. In fact, very specific gases in Earth's atmosphere act like clothing. You might have heard of these gases as greenhouse gases. Gases like carbon dioxide and methane. We like to call them heat-trapping gases because they trap some of Earth's heat energy in the lower atmosphere and keep it from escaping into space.
A certain amount of heat-trapping gas is good. It keeps our planet from freezing over. In terms of clothing, it's a bit like wearing a cozy flannel shirt on a cool evening.
But let's imagine the atmosphere was filling with more and more heat-trapping gases like carbon dioxide. Well, that's just like putting on more and more layers of clothing. Maybe an extra sweater and some scarves, then a winter coat, a toque. Pretty soon, the Earth is all sweaty and uncomfortable.
And cranky, too.
Yeah, probably cranky too.
It's easy to show that the atmosphere has been filling up with more of these
No
heat-trapping
machine.
gases than normal.
There are no more sheep.
Bo, please call up the carbon dioxide chart. Here you can see the very real rise in atmospheric carbon dioxide over the past 7 decades. If we compare the rise in carbon dioxide to global temperature over the same period, you can see how the global temperature has risen steeply along with the increase in carbon dioxide.
Bo, can we see these charts over a longer period? Even over a very long period, you can see how levels of carbon dioxide started to spike just in the last century. And what did humans start doing more and more of in the last century? Carbon dioxide levels in the atmosphere have risen dramatically ever since you humans started burning fossil fuels like coal, oil, and gas to make your energy.
These specialized cameras can actually see the carbon dioxide emitted by your modern lifestyle. And high above us, satellites are detecting the same heat-trapping gases that continually flow into the atmosphere from your major cities. As change agents, you have to realize that the only way to keep the global temperature from rising past the critical point is to drastically slow down the flow of these heat-trapping gases.
We've shown that the Earth is heating up and we looked at what's causing it. But just how does a warming planet change climates? That may seem obvious, but we'll find that a warmer atmosphere affects climates in all sorts of interconnected ways. Luckily, we have agents out in the field to walk us through some good examples.
Bo, can you please see if there's a change agent available to speak to us? Oh good, Agent Dad. She studies climate change in polar regions. She's great. And a friend of mine. Hi, Christine. We have some new trainees here who want to understand how a warming planet affects climates.
Hey Felicity, good to see you. Sure, let's talk about the Arctic and climate change. So, it's a well-known fact that the Earth is warming as a whole. But did you know that the Arctic is warming twice as fast as everywhere else? So, you know on a sunny day, a sheet of ice is really bright and shiny. That's because it's great at bouncing energy that comes in from the sun back out into the atmosphere. Problem is, if that sea ice starts melting, then it can't bounce that energy back into the atmosphere, and instead it gets absorbed into the ocean which gets warmer and warmer and then melts even more sea ice. And so you could think that perhaps this doesn't affect you directly. However, changes in the Arctic are going to affect everybody in the world. One of the reasons for that is that as the Arctic Ocean warms, it changes global ocean currents. And those currents are really important for regulating temperature all around the world, both on land and in the ocean. Another example is how weather seems to be changing quite rapidly over the space of a few days. This is because a warming Arctic is making the jet stream more wobbly. And this is bringing cold air down from the north one day and then warm air up from further south the other day. And that trend is getting more extreme over time. So those are just two unexpected ways in which a warming Arctic can affect climates around the world and everyone in it, including sheep. Well, I hope that was helpful, and good luck with your training.
Thanks, Christine. Appreciate it. So, the point is that the ongoing warming of the planet disrupts the usual patterns of climates, and that has a big effect on all living things.
The Arctic is just one example of ongoing climate change. There are so many ways that a warming planet is impacting the world.
I have an idea. We have agents out there in the field who specialize in tracking these impacts. Let's see who's online, and then, as a group, we'll choose who we want to hear from. On the tablet in front of you, choose the topic that interests you most by touching the image. You've got 5 seconds to make a choice. 3, 2, 1. Okay, the choice has been made. Bo is connecting us now. Hi, George. Glad we caught you. Do you have time to talk to us about your work?
I would love to. Hello, everyone. It's good to see you again. I should probably start off by giving you an update about your float. So Sheepy, the float, was launched in March of 2020, and it has been reliably sending back data every 10 days ever since. So it's working really, really well out there down in the Southern Ocean. And this is part of a much larger project called SOCOM, which stands for the Southern Ocean Carbon and Climate Observations and Modeling Project. That's a real mouthful, so we just call it SOCOM. And this float, your float, is one of over 130 floats that are down there collecting data for us so that we can get a better understanding of what's going on down there. These floats, like Sheepy, are equipped with a whole suite of sensors that we use to measure the ocean. Once we put them into the water, they'll go down and they park at 1,000 meters. And they sit there at 1,000 meters for 10 days. And then on the 10th day, they'll go down to 2,000 meters. And then once they hit 2,000 meters, they'll go all the way up to the surface, collecting data on the way up. This float and your float, Sheepy, is part of a much larger program where we're trying to get a better understanding of what's going on in the Southern Ocean, which is a remarkably difficult place to study. Because the ocean is responsible for absorbing so much of the heat and the carbon dioxide, it really serves as the engine for our weather systems, which lead to our climate